Hi guys, welcome to another video, and today we're looking at kinetic energy. Now, kinetic energy is the energy an object has due to its motion, and it all depends on its mass, which is measured in kilograms, and the object's velocity, which is measured in meters per second. This is one of the trickier equations in physics, but if we follow this example, it should make some sense and it should be quite easy to use in your exam. Well, kinetic energy, and I'm just going to use the symbol EK, kinetic energy is equal to half of the mass of the object. And then what we do is we take a square of the velocity. In your exam, it will look something like so, where mass is measured in kilograms and velocity is measured in meters per second. And kinetic energy is measured in joules. Well, let's take a look at this example and let's see if we can apply this equation to a typical question that you could get in your exam. And it says a 20 kilogram ball is moving at 2 meters per second. So it has kinetic energy. And the question is saying, calculate the kinetic energy. Well, what I would do is, first of all, is just write out my equation first. And I can see that it doesn't need rearranging. So I can plug the numbers straight in. So I would do half of the mass, which is 20. And I would times it by the velocity squared, which is 2 squared. What people tend to do is to type all of this into a calculator, which could throw out a wrong answer. So I would advise you guys to work this step out separately. So the first thing that I would do is type 0.5, as that's half, and I would times it by 20. That will give me a value of 10. That's half of the mass. And then I would times that by the velocity squared. The velocity is 2, but if I square it, 2 times 2 gives me 4. So I can quite simply now do my calculator 10 times 4, which would give me 40 joules of kinetic energy. You may also come across in your exams, guys, elastic potential energy. And this is quite simply the energy that is stored in an object when we stretch it. If you think of like a bow and an arrow, that if we stretch that bow, then there's elastic potential energy stored within that bow. Okay guys, thanks for tuning in. Stay in touch for another video.